about enantiomers. It's important to understand enantiomers because some drug products on the market are single enantiomers and some are racemic mixtures. Some enantiomers have a vastly different mechanism of action or even therapeutic outcome, and some of them have similar therapeutic outcomes. Some examples are like escitalopram and citalopram, or Lexapro and citalopram, and esomeprazole and omeprazole, or Nexium and Prilosec. What is an enantiomer? An enantiomer is a stereoisomer that is non-superimposable onto its own mirror image. I'm gonna explain this the best I can. Isomers are one or more compounds that have the same molecular formula but different arrangement of atoms. Stereoisomers are isomers that differ in the spatial arrangement of atoms but not atom connectivity. There are a couple different types, but I'm gonna focus on enantiomers. I really like this picture, but remember, enantiomers have the same molecular weight and molecular formula. We see here that, okay, those two atoms fit in those little holes in this receptor, but oh my god, the little purple thing fits here, but it doesn't fit over here. Sometimes this matters with drugs, because sometimes one enantiomer can work and one can't, or maybe one is causing side effects and one doesn't, but sometimes it doesn't matter. So it's easy to see if you build the structure, like with levoamphetamine and dextroamphetamine, because this little amine group, when attached right here, is a different structure. This carbon right here is called a chiral center because it's attached to 4 different atoms: a hydrogen, a methyl, an amine group, and then the rest of the structure. Dextroamphetamine is more potent than levoamphetamine. Adderall is a mix of 4 different salts. We have 2 dextroamphetamine salts and 2 amphetamine salts. Amphetamine is a racemic mix of dextroamphetamine and levoamphetamine. So Adderall is a mixed salt of 3:1 dextroamphetamine to levoamphetamine. So again, dextroamphetamine is more potent than levoamphetamine, meaning that a smaller amount of dextroamphetamine will produce the same response as a bigger amount of levoamphetamine. So when converting a patient from Adderall to Dexedrine, you're gonna have to have a smaller dose of Dexedrine to produce the same response of Adderall, so a dose decrease. Another example I'm going to talk about is albuterol, which is a 50-50 mix of the R and S isomer. Levalbuterol or Zopanex is the R isomer. Levalbuterol or Zopanex is branded to be a better alternative to albuterol, having a better side effect profile is what it was said. A few studies actually looked at this claim. This systematic review showed that levalbuterol was not superior to albuterol regarding efficacy and safety in subjects with acute asthma. So basically no difference in tolerability and clinical outcomes. I will mention that I have had some patients report less tachycardia or tremor with levalbuterol over albuterol. This is another little study I found in the American Academy of Family Physicians. Albeit a small study, there's really no difference with side effects between them. The cost can be really different for patients. So albuterol is about $18 with the GoodRx and levalbuterol is about $60 with the GoodRx. This is at Walmart. Probably one of my favorite examples of enantiomer differences is dextromethorphan and levomethorphan. We all know dextromethorphan. It's in the cough syrups, Robitussin and Delsum, and it's also in Nudexa for pseudobulbar affect, and then Auvelity as well for major depressive disorder. This isomer, levomethorphan, is actually an opioid. They're in the drug class called morphinins. Dextromethorphan is interesting because it acts on a bunch of different receptors like sigma-1. It's a weak NMDA antagonist, and then it's also a serotonin and norepinephrine reuptake inhibitor. Its metabolite dextrorphan also has higher binding affinity to the NMDA receptor. Antagonism at this receptor is what causes its dissociative and hallucinogenic effects, especially at higher doses. But dextromethorphan undergoes O-demethylation by CYP2D6. See, we have this little O-methyl group up there that turns into a little hydroxyl. Dextrorphan. Levomethorphan does the same thing to a drug called levorphanol. Levorphanol is multiple times more potent than morphine. It predominantly acts on the mu-opioid receptor, but also hits kappa and delta, and it also has SNRI activity, as well as NMDA antagonism. Here's a side-by-side of my original structure if you want to look at it. Another side-by-side of levoamphetamine and dextroamphetamine.